Section 8.2 is on adding and subtracting rational expressions. Remember, rational expressions are basically just fractions that have polynomials in the numerator and denominator, and like any fraction, in order to add or subtract them, you must have a common denominator. To find the least common denominator, we want to find the least common multiple, or the LCM, of the denominators. To find the LCM, we're going to factor the expressions and keep each factor the greatest number of times it appears as a factor. Let's take a look at a couple examples here. So, given these monomials, 12a squared b, 15abc, and 8b cubed c to the fourth, we need to find the LCM. So, let's factor the 12. 12 is 4 times 3. 4 is 2 squared times 3 times a squared times b. You want to keep them with the exponents. 15 is 3 times 5, and then we have an a and a b and a c. And 8 is 4 times 2, and 4 is 2 times 2, so that's 2 cubed times b cubed times c to the fourth. Now notice I have, I think, 6 distinct factors. I have 2's, I have 3's, I have 5's, a's, b's, and c's. And I want to keep the biggest one of each of those. So I have a 2 squared and a 2 cubed, so I want to keep the 2 cubed. 3, both of those are just 3 to the 1, so I'll just keep one of them. I only have 1 5. My highest exponent of a is a squared. My highest exponent of b is b cubed. And my biggest exponent of c is c to the fourth. So my LCM, my least common multiple, which is also going to be the same as my least common denominator, is going to be 2 to the third times 3 times 5 times a squared times b cubed times c to the fourth, or 120 a squared b cubed c to the fourth. So in other words, if I had 3 fractions and these were my 3 denominators, this would be my least common denominator. Let's take a look at an example that involves some trinomials here. We need to factor each one of these. X cubed minus x squared minus 2x squared. First thing I notice is that I can take out a common factor of x, and I'm left with x squared minus x minus 2. That trinomial can be factored into x minus 2 times x minus 1. So that's the fully factored form of my first trinomial. X squared minus 4x plus 4 is actually a perfect square trinomial. That's x minus 2 times x minus 2. And I'm going to write that with the exponent, x minus 2 squared. So looking at these factored expressions, I believe I have 3 distinct factors. I have an x, I have an x minus 2, which appears in both of them, and I have an x minus 1. So I need to choose each factor the greatest number of times it appears. So there is only one x. For the x minus 2's, there's actually 2 of those, so I'm going to keep this one, and there is only one x minus 1. So my least common multiple is going to be x times x minus 2 squared times an x minus 1. That would be my common denominator if I had 2 fractions with these expressions as their denominators. So using that, let's simplify a few expressions here. So I have 4 over 5a cubed b squared plus 9c over 10ab. First thing I want to do is figure out what is my least common denominator. So I need to find the least common multiple of these 2 expressions on the bottom. Well, looking at the 5 and the 10, 10 would be my common denominator. Take the greatest exponent of a and the greatest exponent of b. So that's going to be my common denominator. So I need to rewrite each of these fractions with that denominator. 10a cubed b squared. Okay, now what do I need to multiply 5a cubed b squared times to get 10a cubed b squared? And that would be just a 2. I'd have to multiply both the top and bottom by a 2. So that's going to give me 2 times 4, that's going to give me an 8 here. Now, what do I need to multiply 10ab times to get 10a cubed b squared? I'm going to need to multiply it by an a squared and a b. So this needs to be multiplied by an a squared and a b as well. So that's going to give me 9 a squared bc. I like to put them in alphabetical order. And now, remember when we go to add fractions, when they have the same denominator, just add the numerators. 8 plus 9 a squared b cubed. I'm sorry, 8 plus 9 a squared bc over 10 a cubed b squared. And remember, I cannot combine the 8 and the 9 because the 9 has all of these variables along with it. So there's my final answer. And our last example here, x minus 1 over x squared minus x minus 6 minus 4 over 5x plus 10. So let's factor each of our denominators so we can figure out what our common denominator is going to be. X squared minus x minus 6 is going to factor into an x minus 3 and an x plus 2, and 5x plus 10 factors into 5 times x plus 2. So my common denominator is going to be a 5 and an x plus 2 and an x minus 3. So I'll rewrite each of these with that common denominator. And this does get a little tedious. It can be a lot of writing, but I think it's very important to do this so that we can keep track of what we need to multiply each thing by. The other thing I'm noticing about this problem is it's a subtraction problem. So I think what I'm going to do is I'm going to make this a positive and make this a negative 4 on top. Or actually, I'll just leave the negative there for now. Okay, so here's my original denominator of the first fraction. In order to go from this denominator to this denominator, I need to multiply top and bottom by 5. Okay. Here's my original denominator of the second fraction, 5 and an x plus 2, but I'm going to need to add to that an x minus 3, top and bottom. Okay. Now, 5 times x plus 1 is going to be 5x minus 5. Did I say x plus 1? X minus 1. And let's make this, let's go ahead and make this here plus a negative. And I'll distribute a negative 4. That's going to give me a negative 4x plus 12. And now for my final answer, just combine like terms across the top. 5x minus 4x gives me an x. Negative 5 plus 12 gives me a positive 7 over my denominator of 5, x plus 2, x minus 3. And I like to leave my final denominator factored just to make sure that there's nothing else I can cancel when I get to my final answer. So to sum up, to add and subtract rational expressions, it's a lot like adding and subtracting fractions, just looks a little more complicated. You still need to find a least common denominator before you can combine the terms.